Hello, I'm John Gertz. I describe myself as a SETI theorist. SETI, of course, is an acronym which stands for the Search for Extraterrestrial Intelligence. You can go to my website, johngertz.com, and it will lead you to a link to my various peer-reviewed published papers on topics related to SETI. I'm going to describe this series or title this series of videos Reinventing SETI because that's really what I want to do. I want to get under the hood, uh, rip apart all of the common notions of SETI that have governed the science and the operation of SETI for the last 60 plus years, and try to answer the question: Are we doing SETI in the best possible way? We have to admit that over the 60 plus years of SETI observations, no one has detected any evidence of alien life. So maybe we're doing something wrong. And I think I know what those wrong notions may be. And let's see if we can work towards clearing out some of the cobwebs. The old paradigm of doing SETI, the one that has governed SETI in the more than 60 years that SETI has been active, uh, is one of looking for electromagnetic signals that one civilization is sending here to Earth using either radio or optical waves. Both are part of the electromagnetic spectrum. And there's a great advantage to this. And it seemed to make sense at the time to look for these types of communications or transmissions. First of all, light is fast. As a matter of fact, nothing is faster than light or radio waves. It travels at the speed of light. Um, that's one great advantage. The second great advantage is that it's relatively cheap, over the short term at least, to create electromagnetic waves. The third advantage is that the galaxy is pretty transparent to radio waves and transparent enough to optical waves so that a laser at a distance of 1,000 light years can certainly illuminate the Earth. After that, you begin to run into a problem where dust can obscure the laser. Uh, but if we turn the situation on its head, let's ask whether or not this is, however, the optimal paradigm or a good paradigm for ET. But I'm not certain that transmitting electromagnetic waves from one's own star system to Earth would be a particularly good idea for ET as a strategy. First of all, ET is going to have to admit that it could be quite dangerous to do that. There may be some very dangerous actors in the galaxy, and ET may have solid reason to know, or at least to believe, that the galaxy is potentially dangerous. And the one thing you do when you send a message from your own star system is, by virtual definition, you tell everybody where you are. You're giving the galaxy directions to your civilization, its coordinates. The second particular problem is that although it is cheap to send electromagnetic signals over a short period of time, ET has no a priori reason for understanding when it is that we here on Earth become a technologically competent civilization who can receive that message. They may have had to have begun their transmission 1 billion years ago, and with no idea whether and when we would pick up that message and do so 24/7. In other words, all day, every day, no matter how long their particular day is, to be sure that our receivers are looking at them at the time that they're transmitting. If we're not the only star system that is of interest to them, and I can't imagine why we would be out of the billions and billions of star systems in our galaxy, then they've got to have a transmitter dedicated to each and every star system that they wish to target at enormous expense. So alternatively, they can do what we do. We look at stars sequentially, one by one. We point our big telescope at this star and that star and the next star and the next star, and we go through long lists of stars. To date, we have looked at approximately 1 million stars. Well, certainly at least 1 million stars if you also include those that are in the foreground or the background of the intended star system. But we, but but the question becomes, if we're looking at 1,000 at 1 million stars and we're doing so sequentially, it takes us perhaps 10 years to cover that full 1 million stars. We do so by looking at each one for about 10 minutes each before we move on to the next one. And this is actually the ongoing predominant protocol for all SETI observations. Now, let's imagine that they also have lists and lists and lists of appropriate stars that they wish to target with their message and to transmit their great wisdom or knowledge or whatever it is they want to transmit. And they too are doing it one by one by one by one by one. And it takes them also, with several telescopes or transmitters working at the same time, also 10 years to cover the million stars. These are reasonable presumptions. Well, the chances of our receiver, or their receiver, I'm sorry, and our telescope aligning in exactly the same 10 minutes out of the 10 years is, of course, basically negligible. So it's not a very efficient paradigm. In a subsequent video, I'm going to get deeper into the weeds of this particular protocol, the idea that alien civilizations are transmitting from their home star system to our star system in the hopes of making contact, and show that all the myriad of problems that are attendant to this particular protocol. However, for now, let's move on to a better protocol, what it is that I really think that ET may be doing. So, in my judgment, ET's better strategy is to send robotic probes to our solar system. Those probes will be much slower, of course, than the speed of light. They could be quite slow. It could take them 50,000 years to get from one star to another, even a nearby star. It could take them 1 million years to go from their home planet to our solar system. But who cares? In deep time, this amount is just an eye blink in the course of the history of the galaxy. What they could be doing is sending probes to our solar system early in our solar system's history. Let's say a couple of 100 million years after the birth of our star, 4.55 billion years ago. If they had sent a probe into our solar system, they may have noticed that the planet Mars was blooming with life, but Earth was still a molten rock. That might have egged them on to send another probe, perhaps another 100 or 200 million years later, to go by and fly by the solar system, at which time they may have found out that Mars had turned dry and inhospitable to life, but suddenly life has blossomed on Earth. That, of course, will lead them to send additional probes. So notice what's happening here. When they send transmissions at the speed of light to us, those transmissions return no information to them, none whatsoever. If they fly by with probes, they're actually able to do science and to learn something about us. Well, they may have sent additional probes, perhaps every 100 million years, to fly by. And sooner or later, or roughly 2.5 billion years ago, they would have seen some signatures of oxygen and realized that maybe life is developing some ability to become multicellular. This may have led them to plant probes into our solar system so that they actually begin to orbit our star and do some ongoing science. Now, if their intention is to download to us great knowledge or wisdom or whatever it is they wish to convey to us, the cost of doing so by sending that same information physically by probe is vastly cheaper than the cost of sending it by electromagnetic waves. Now, I said earlier that electromagnetic waves are cheap to send. That is very true. For a day, they're cheap. But for 1 billion years, when you compare the cost of sending information over 1 billion years to the cost of sending it physically in a probe that might be the size of our Voyager or Pioneer spacecraft, and it becomes much cheaper. The information payload itself could be on effectively their version of a hard drive or a thumb drive or something. Um, it would need some propellant, some shielding, uh, so, the ability to transmit information backwards to their own star system, perhaps, but it's not going to demand a lot more than that. Um, the cost per bit of information conveyed that way is vastly cheaper than that conveying that same bit of information over electromagnetic waves. And remember that that probe need only be launched once. In effect, it's a message in a bottle, um, one and done. When you compare that to the potentially millions or billions of years of transmission time, again, the cost analysis is very favorable to the probe. Um, but a probe orbiting our own solar system now can do more than just convey information to us. They can study us and learn about us and learn deeply about us. They could have been monitoring our television signals since the 1950s, and in fact been watching episodes of I Love Lucy, our nightly news, and so forth. The probe could have picked up our languages from Sesame Street, our math from Khan Academy, all the rest it could have learned from YouTube. In short, it can surveil and know a great deal about us long before it actually deigns to communicate with us. And when it does decide that it's ready to communicate to us, it might be able to do so in the Queen's very own English, or in Urdu, or in Hindi, or Mandarin, or whatever. Now, there's a problem attendant to the to and from response time with a star at 100 or hundreds or thousands of light years distance. That civilization will have will be sending signals to us, and we have to analyze it. We have to decode it and decide what we're going to say in return. But the call and response time to a star at 1,000 light years is, of course, 1,000 years for our message to go there, 1,000 years for their message back in return to us. So I don't know. Let's imagine that we did such a thing, and I know we had no ability to transmit 1,500 years ago. Let's imagine that our ancestors had the ability to send messages to ET. Let's imagine that 2,500 years ago, a civilization had decided to send a message to a civilization that was 2,500 light years away. What we would send, perhaps, would be information about the heights of our great pyramids and ziggurats. It might have We might have given a sample of our greatest literature, Gilgamesh. We might have given them instructions to how to properly pray to the sun god Ra. And we might have given them our most advanced math, which would be addition and subtraction, without any reference to zero, which had not yet been invented. So what is their response going to be to us? We would get that response if the civilization was 1,500 light years away. We'd be getting the response back right now. It would be their critique of Gilgamesh. They might show us how to do long division. They might tell us how to build an even higher pyramid, and how to break this to us gently. They might inform us that indeed a star is not in fact a god. It wouldn't be terribly useful information. But a probe in our own solar system would be able to enter into a dialogue with us in near real time. That probe might be just a few light seconds or a few light minutes away from us. And so the back and forth would be for all intents and purposes, almost instantaneously and consequently exactly relevant to our current situation. Probes also solve for what Drake called the L problem in his Drake equation. That is, that civilizations have to coexist in order to communicate star by star, star to star, adjusted by the speed of light. So if a star system is communicating to us for 100,000 years, but we only build our first radio telescope or optical telescopes that's able to receive that message in the 100th and 1000th and first year, in other words, a year after they've gone extinct, obviously we're never going to get that message. It's gone. So civilizations have to coexist in order to communicate using the standard SETI protocol of looking for star to star communication. Um, Probes solve that. Once the probe is launched, it's nice that the progenitor civilization sticks around, but it's not necessary. That just as our Voyager and our Pioneer spacecraft are gone from our solar system, never to return, uh, these probes are also gone, and quite independent whether the Earth and humanity persists as a civilization. Voyager and Pioneer are going to persist and go out for the indefinite future into the galaxy. However, there is a problem with my hypothesis that ET would prefer to send probes than to transmit information from its own star system. And that problem is one of receiving information back again. The probe that I've imagined up heretofore up to this point is basically a message in a bottle. It's one-way communication. It's them downloading their Encyclopedia Galactica, their wisdom, their religion, their science, whatever it is they want to send to us. But they receive nothing back in exchange. There are solutions, however, and those solutions will be the subject of our next video. Thank you. Again, if you want to learn more about myself, go to johngertz.com and you'll find there links to my peer-reviewed published papers and information of my forthcoming book entitled Reinventing SETI that will be published by Oxford University Press later this year. Thank you.